All right, so here we're supposed to sketch the accumulation function graphs. And then we're supposed to start from a to x and then b to x. All right, so what happens from a to x? Well, here, this is when the accumulation at a is equal to 0. And this is when the accumulation at b is equal to 0. So that's where we want the zeros to be. When it's at a, we want it to be 0. So that's going to be where we kind of start. And when we have the b, we want the 0 to end up here. And so kind of we're going to offset the graph basically for that one. So let's do 11 first. We'll do a at the beginning. So we're going to have some kind of a up and down because it's going to be, it's negative until we hit that point, and then that's going to be our minimum because we're going to go from negative to positive, and then we're going to start going up from there, and then we're going to hit a max change in a max change in a rate of change. So that's going to be kind of our inflection point, and then it's going to start slowing down, and we're going to hit our point from positive to negative. So that's going to be our peak, and then after that, it's going to start going down from there. So let's call that our A. Let's say we have a B here. So again, we said we're going to go down, and we're going to change from the position here, and that's going to be actually a minimum at that point here on the 0 axis. And so then after that, we're going to start going up, and is it going to disappear on me? Yep. And we're going to start going up, and we're going to hit a max at our B. Okay, because that's going to be where the max is. Here it was an inflection point, so our inflection point is somewhere here. And then after that, we're going to start coming down again until we hit our axis. Okay, and that's probably going to disappear, so I'll draw it again. All right, so that's what it's going to look like. Now, if we want this to be 0 at B, we basically are just going to offset everything for our function. So once we draw our first one, our second one's not as hard. It's still, I can't draw very well. So what we're going to do is we're going to come down. We're going to have more down here now. So we'll come down by about that much, and we'll go like this. And that's supposed to touch there. Okay, and so that's going to be kind of what you have for graph being offset with that B, starting at B going to X. Now, what about 12? Okay, well, here we're going down, and then we're going to kind of plateau. We're going to be crossing over at that 0. So that's still going to be, kind of like here, we're going to have a point where it's crossing at 0, but this is a bigger plateau here. It's going to be really flat at that point. And then after that, then it's going to start going back up. Okay, so let's see if we can draw that. So again, let's say that's A, that's our B. So it's going to be decreasing, and then it's going to start getting really flat, and then it's going to start increasing again. Okay, so something like that. Now that's for A. For B, what's going to happen is we're going to offset it, and so this time it's going to be more going the other direction, because now B has to give us the 0, so it's going to be moved up, and so now this is actually going to be coming down from up here. Maybe I'll put my points in later, and then we'll flatten out, and then we'll go back up. And so this is our B, this is our A. And so B had to be 0 at that point, and so that's why we had to move this whole graph up as you would until it would actually hit at that 0. Okay, again, not to scale, don't look the same, but that's kind of what it is. And actually, that's not the A there. A is right here. Sorry. Let's write that better. Good. So A is there because that's where we started. All right, so that's going to be kind of what it looks like. So A had to go all the way up, so then we could come down, and then we hit our B here. All right, so again, this drawing these are kind of hard, but that's the concepts are what we need to know here. Let's do one last set here, 16 and 18. So it says identify from the graphs A through F, and so we have A through F over here, the derivative graph and the accumulation graph. So for this here one, so the derivative of this and our accumulation of this with x is equal to 0 as a starting point. Okay, so we're just starting at 0 of our graph. So A through F may be used more than once, so we can use it here and here if possible or if need be. Now, that's the case if you have 16, 17, 18, and probably 19. So let's do 16 first. So we need a derivative and we need the accumulation. Okay, so thinking about this, so the derivative of this. So if we take a derivative of this, this is, if we think about what is this equation, well, it's something like y equals a negative mx plus b, because we have a straight line going like that. And so if we take the derivative of that, what do we get? Well, that's just going to give us y prime is equal to what? A negative m. And so sometimes, instead of going and trying to think, oh, what does the graph look like? Sometimes think about what the equation looks like, and then finding this over here is going to be a lot easier. So here we have a negative m. So that's just a straight across y equals negative m. So, m is whatever this is. So that's a negative m. And so that's what we have. So that was, first one. We didn't even have to go anywhere. So that was equal to a. Now for the accumulation function. All right, so we're going to be accumulating. So we're going to be negative. We're going to be, it's going down, it's decreasing. So we're going to have a negative value for going up to the point A. And at point A, we're going to switch from positive to negative. So that's going to give us a max. And so we're going to have a max at A, basically. And then after that, we're going to go and we're going to go down some more. So it's going to be, something like here, we have to have a negative or have a max at A. So max at A, well, the only one that has a max at A is that one. And so it looks like we'll have something like that. So it's positive, we're getting lower, and then it goes to the max, and then we're going negative here. And so that's going to be kind of what it does. We're reaching the point, we reach the max, then we start going down after that. So it looks like C would be the value. Now 18, well, what's this one? Well, that's y is equal to, well, if we go up, it's x squared, so this has to be a negative x squared. So y prime is equal to what? Well, negative 2x. All right, so our derivative has to be in a line that looks like a negative 2x. And so which one looks like a y equals negative 2x? Well, probably B. That would be my best guess. Now this one, what are we going to get for our value here? Well, our value, we're increasing, so it's going to be positive for accumulation. And then what happens is we're going to hit the max here. And so that's going to be kind of our 0 at this point. And then we're going to go down. So these are all kind of going like that. So let's see, if we do that and our A is going to be kind of a 0, that could be a 0 there. If we think about the flatness there, that could be a 0. We don't even have it in here, so that's not even a possibility. So we're still going that way. That might be a possibility. That one's not. I think it has to be D. So D would be our accumulation function for there. So that's, again, you just have to, if we had our values, that's how it would look there. All right, so, oh, we have one more. All right, so the next table gives 3 functions with the same input. Identify the function g and the function h. Okay, so these are g, this is our h, and it's going to be either rate of change or accumulation. All right, so let's say our h of m, and so our g of m. And so what are we doing here? So as we go down, We have a -3, we have -12, then it goes 0, then it's going up. Okay, now this one, we're going negative, 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 then 0, then 125. And it's based on this. So here, if we think about it, we're going down, that's negative. We're going down again, that's negative. Then all of a sudden, it seems like we've kind of peaked out. And so then we've kind of have to stop. And then we're going to go up and go up again. And so, if we're going that way, so it's going to look something like uh, this, and then it's going to go up like that, it looks like. And so which one is going to be a derivative and which one's going to be that? So so this is probably a parabola type, so that's going to be that. So I think what we're going to have to do is this is going to be more negative than this one. This is going to again be negative, but where is it going to be doing? It has to be crossing the axis because we're going from negative to positive. And so this is where we cross the axis. And so this then is, what are we doing? Now we're adding, so it goes to 0. So if we're adding here, it goes to 0. And here we're adding even more, and so we're positive. So I'm thinking H, and then I'm doing this one because I can write over here. H has to be our accumulation. And so G then would be our derivative, our rate of change. And so does that make sense? If that's the most negative, so that would probably be a trough. And so, that would be here. And so if we take the derivative, that's going to give us a 0 derivative at that point. So that makes sense. And that would be our derivative. All right, so I think that then is all. Yes, so hopefully that helps you on some of the homework.